Hello and welcome to this presentation as part of the Road and Construction Drainage Principles major assignment. My name is Thomas Noone and I will be giving this presentation over the next 15 minutes or so. This presentation accompanies a written report, and the topics raised within this written report will be discussed over the next few slides. In summary, there are four main elements to the report. These are water management, embankment construction, roadsides, road reserves and flora and fauna, and project planning and sequencing. In addition, the key issues within each of these elements will be discussed, along with some conclusions and recommendations towards the end. Lastly, there are several references to material which has not been referenced in the written report but is included in these slides, and these references are provided at the end of this presentation. To give an overview of the project, this is a road deviation which is 2 kilometers long in a two-lane, two-way rural highway formation. It is located just outside Darwin in the Northern Territory, Australia. Predicted traffic volume for this road is 590 vehicles per day, with 5% of those being commercial vehicles. The posted speed for this road is 80 kilometers an hour, while also we need to maintain access to historical places of interest. As you can see from the image provided, there is a rough long section generated by Google Earth. So the plan is here. The proposed tie-in is here at this end on the western end, and the eastern end of the proposed tie-in is approximately here. The long section following this alignment, as you can see, is a high point. We come into some low country here. There's a creek flowing through the center, and then back up to an area which is has been deemed as having some exposed weathered rock. It is worth noting that this location has been chosen to illustrate the project rather than define it. The alignment actually shown of the existing road is a 4-lane highway. However, it is just used for location purposes. And that's 2 lanes in each direction. So a site plan has been marked up here showing the elements that need to be considered in the construction of this project. I'll turn on the pointer again. We've got a creek which is indicated by this blue line here, an existing creek, so we have to allow for a crossing somewhere along the center of the alignment, likely being a pipe culvert crossing, a reinforced concrete pipe. Proposed rest area and historical information visitors area is proposed for here. The marsh area is about 300 meters long. It's indicated by this green line here. That's the area of exposed weathered rock which I mentioned earlier, and the creek flow is from the northeast to the southwest as shown here. In addition to the physical constraints on site, that we also have to be cognizant of the threatened species, which is a swamp wallaby. So there's some fauna issues to attend to at the site also. As already stated, there are 4 primary areas of this, the focal points of this report, being water management during the construction phase and also post-construction. Also looking at the detail and embankment construction for this project and the methods we're going to use. Also taking into account the roadside, such as safety barriers and fauna issues, as well as the rest spot for visitors and tourists, and looking at how the project should be sequenced in terms of construction. So looking at the first element of the report, water management during the construction phase, there are several key issues which we need to discuss. These are how the culvert crossing is constructed, noting that the water table in this area is 0.3 meters below the natural surface of the marsh, in the dry season, but that rises to 0.5 meters above the natural marsh surface during the wet season. The bottom of the creek bed is 1.2 meters below the existing surface, so in any condition, dry or wet season, we will be in the having groundwater issues. It's suggested that there's a creek diversion put in upstream to divert the creek around and take that water away and hopefully drain a little bit. In the written report, there are several other options provided as a manner in which to deal with groundwater issues. In addition, water quality, sediment control are very hot topics in the Northern Territory due to the stormwater events that we do get up here. These need to be controlled by the contractor in terms of sealing the site and ensuring there's adequate control, such as sediment basins installed. And in addition, it is always important to remember health and safety issues when constructing works. In this particular area, crocodiles do inhabit all the water, pretty much all the waterways in the NT, so always worth looking out for them, and also looking at trench stability and potentially shoring or trench boxes, as can be seen in this slide. So moving on to water management in the post-construction phase, the key thing here would be maintenance and making sure the road authority ensures that they monitor for blockages through the culverts and keep these clean and clear. Otherwise, we may get flood waters building up behind the formation of the road and possibly eroding the embankment or overtopping and creating issues in terms of accessibility. In addition, any subsoil drainage that's installed and weep holes within head walls and so forth needs to be kept clean and ensure that groundwater pressure can be released through these avenues. Also, vegetation that grows, this should be maintained so that any roadside drainage will work effectively, but the grass coverage does help as a scare mitigation and water treatment element as well. Also, it's worth noting that public safety at culvert crossings in the NT is a little bit of a concern. Fishing activities are often taking place around culverts where you get fish activity, always popular with the locals. So moving on to the second element for discussion of this report, which is embankment construction. So as previously stated, the embankment should only really be constructed in the dry season, otherwise it presents significant issues with stormwater runoff and also between subsurface and surface flows. So as part of the identification of where fill can be sourced from this project, the exposed weathered rock at the western end of the project on the high point has been identified as a fill source. It has been assumed that the designer has balanced the earthworks across the job and that there is enough source material here to use across the entire embankment. As well, this sketch here has been provided to illustrate the soil conditions at the culvert crossing and across the formation. I'll just use the laser pointer again to give an idea of what's happening. So this level here is the existing marsh surface. We have organic soils for about 250 mil deep on top. The next layer is heavy and expansive clay with a CBR of 3, and that's 550 mil thick. And the bottom of that is at minus 800 mil under the marsh surface, and then under that is a clay gravel layer with a CBR of 8. This gravel layer appears to be reasonably effective and would be a good founding base for our stormwater pipes, and you can see where they'll be constructed within that layer based on the invert of the pipe matching the current invert of the creek bed. In terms of the material on top of these layers, there are 3 treatments which are going to be discussed for treating these materials, the organic soils, the heavy expansive clays, and how we load the formation on top is discussed here. So it's considered that the fill that'll go on top of whatever treatment we use in here will be a consistent process. Using the weathered rock source, we'll use it probably a dozer to rip that, and then we'll haul with scrapers because it's a bit beyond the length of a preferred length for a dozer to push material. So we'll haul with scrapers, and then we'll place with graders and rollers we'll use to construct the formation. So looking now at the three embankment construction options for constructing the founding layers, option 1 was stabilization, option 2 was the use of geotextiles and rock blanket, and option 3 will be remove and replace the existing material. Option 1 is considered the preferred method in this case because and it's going to be a wet soil mixing process which is based on the Keller technology, which was used pretty nearby a few k's up the road for the recent Garmilla Drive update. The wet soil mixing process is a process whereby a mixing head is placed onto an excavator which is driven into soil to a specified depth which is predetermined, and a slurry of cement, a cement slurry is pumped in at that depth and brought up through the soil layer and stabilizing it in that manner. One of the big benefits of this treatment process is that it'll also treat the clays and the organic soils on top, so there's no spoil having to be removed from site, which will speed up the process. So after it's stabilized up to the top of the organics level, there'd be a geotextile fabric rolled out on top, and then a layer of at least 300 mil working surface pushed out, and the excavator can advance along the embankment in this process. It's suggested that they work from either side, provided there's enough equipment. One of the drawbacks to using this process, however, is that this equipment isn't based in Darwin, so it would have to be brought in, especially for this project. I'll just put on a little video now of this process on the Garmilla Drive upgrade project. This coincidentally was actually taken from where figure 9.16 on page 19 of topic 9, the unit text, was taken from. So interesting that it was taken so nearby. So you can see the mixing head being extracted now and the cement slurry being mixed through as the head comes out. So looking at the third element of the report, this encompasses the installation, the design outline of a rest area for tourists, and this will be for light vehicles for scenic walks. I haven't included a heavy vehicle area in this one because it's considered that there's a heavy vehicle area not too far away in Truck Central in the Wishart area of Darwin, which would cater for truck drivers and resting and rearrangement of trailers and so forth at the road train assembly area. So in this rest area, there'll be some information signs, some access to the walking trails so they can get into the historical areas of interest around the site, and parking facilities and a barbecue facility as well. However, no camping facility will be provided to avoid any long-term stays here. Also in this section, safety barriers is discussed, so there'll be 3 areas requiring safety barriers, which is the approach to the embankment, along the embankment itself, and also over the creek crossing. I've chosen to go with steel W-beam style safety barriers on the approach to the embankment and across the culvert crossing itself. This is due to the steep sections involved here where we don't want traffic leaving the road, and then using a wire rope style along the embankment itself to ensure that any views aren't inhibited from the steel beam type of guardrail. Lastly, due to the fauna in the area, such as wombats, koalas, black wallaroos, and the threatened swamp wallaby, to maintain the recognised travel paths, there'll be fauna under crossings of the road. So pipes will be put in to allow crossings for this fauna, and also climbing bridges, like in the one depicted here, for koalas. Moving to the third element to consider in this report is project planning and sequencing. Some key challenges here are planning the works around the groundwater issues, and this can largely be alleviated or certainly mitigated somewhat by planning works for the dry season only. This will also assist with any weather concerns because the weather is very consistent, which in the dry season and the wet season, it's going to be relatively wet, but the dry season, it's excellent conditions for construction, especially in these low-lying areas when they have to get done. Also, considering the earthworks movements as well, everything is a lot easier in the dry season. And with earthworks, I want to remember the two golden rules, which are never to double handle material, and if possible, load and carry material downhill. So looking at a rough Gantt chart for the works, quite indicative. However, you can see we start off with our pre-construction activities and move into construction planning activities. And then the first works actually on site would be clearing and site setup. So that would also include the establishment of any erosion sediment controls or sediment basins, or potentially a turkey's nest if possible. The turkey's nest, obviously, probably try to establish that a little before the end of the wet season so it'll have a chance to fill up. And then commencing earthworks activities. Very often you commence drainage works before earthworks so you could fill over the top. However, in the case of this project, the earthworks should commence just ahead so that you can fill and make a working platform ahead of the drainage works, and then get the drainage works done and complete the formation, as you can see here. After that, it'll be pavement construction, surface sealing, install safety barriers, signage and line marking, etc., and then finally handover process. Now, just to touch on the conclusions and recommendations following this assessment, it's going to be quite an expensive project with between the ripping of the rock and also the construction of the embankment in relatively challenging conditions. However, time should be saved using the wet mix soil mixing application, and which will limit the amount of spoil that has to leave site as well. Also, with regard to that, this road's going to come at a relatively high cost, regardless of whatever process is used to construct it, and the traffic numbers are very low, being 590 a day with only 5% heavy vehicles, so equivalent to about 30% or 30 commercial vehicles per day. It might be worth considering other options. Even though construction is about to start, it may be better to do this better late than never. And lastly, the road authorities should be advised by the contractor of any maintenance concerns they have when they finish up, or that they've become familiar with, and that'll ensure the safe working of the road in the future. As I said at the start, there's a couple of references to Brutus, the jumping croc in that photo, and to the video provided by Arb on YouTube of the stabilization works just outside Darwin City. And